Section 1.4, using the definitions of the trigonometric functions. Here are the reciprocal identities that we are going to use in this section. Sine theta is the same as 1 over cosecant theta. Cosine theta is the same as 1 over secant theta. Tangent theta is the same as 1 over cotangent theta. Cosecant theta is going to be 1 over sine theta. Secant theta is going to be 1 over cosine theta. And cotangent theta is going to be 1 over tangent theta. Okay, so how are we going to use this? Use the appropriate identity to find the indicated function value. Rationalize the denominator if applicable. So, cosecant theta, it's asking you to find cosecant theta if sine theta is equal to radical square root of 5 over 8. Well, cosecant theta is going to be the reciprocal of that. So basically it's going to be 1 over sine theta, which is going to be 1 over the square root of 5 over 8. And we know that we can flip that and get 8 over the square root of 5, which is going to be 8 square roots of 5 over 5. So basically what are we doing? We're taking the reciprocal. Alright, so cosine theta, if secant theta is negative 5. Well, you know that this is going to be negative 5 over 1. So cosine and cosecant are reciprocals of each other, so all we have to do is take the reciprocal of the secant theta and get 1 over negative 5. Alright, so here is an easy way to know when things are positive and when things are negative. If you can remember a SMART trig class, that's going to help you tremendously, because from here on out, your signs have got to be correct. So when I ask you sign values of the trig ratios, when I ask you to find the trig ratio or the trig function, your signs have got to be correct, because this is what this whole chart is about. A means that all trig values are positive. All trig values. Any trig value found, any angle found in quadrant 1 is going to be positive. SMART, S, that's going to be sine and its reciprocal cosecant. Okay, A SMART, sine is going to be positive and so is cosecant, its reciprocal. Trig stands for tangent and its reciprocal cotangent. They're going to be positive in quadrant 3. And in quadrant 4, class C stands for cosine and its reciprocal secant is going to be positive. So, a SMART trig class, in the first quadrant, A, every trig function is positive. Quadrant 2, sine and cosecant are positive. Quadrant 3, tangent and cotangent are positive. And quadrant 4, cosine and secant are positive. Alright, so here are some examples. Determine the sines of the 6 trig functions of an angle in standard position with the given measure. Well, the first one's 54 degrees. And we know that 54 degrees is in quadrant 1. Well, everything is positive in quadrant 1. So all 6 trig functions are positive. 260 degrees. 260 degrees is going to be in quadrant 3. Quadrant 3. So in quadrant 3, remember a SMART trig class, so trig would be T, so tangent and cotangent are positive, and everything else is negative. So sine, cosecant, cosine, and secant, they're going to be negative. Alright, negative 60 degrees. Remember, negative 60 degrees is a clockwise rotation, so that's going to be in quadrant 4. So in quadrant 4, a SMART trig class, cosine and its reciprocal secant are positive, and everything else is negative. So sine, cosecant, tangent, and cotangent. Okay, identify the quadrant for the angle satisfying the following conditions. Okay, so if tangent is positive, and I know that that's saying it's positive, tangent of theta degrees is anything greater than 0. Anything greater than 0 is going to be positive. So tangent is going to be positive. So we're talking about either quadrant 1 or quadrant 3. And then here it says sine is negative. So we're talking about quadrant 3 or quadrant 4? Well, where is the overlap? The overlap is quadrant 3. So it has to be in quadrant 3. Alright, cosine is less than 0, so that's going to be negative. Where is cosine negative? That's going to be quadrant 2 and quadrant 3. Cosecant is going to be negative. Cosecant's going to be negative, so that's going to be quadrant 3 and quadrant 4. So where's the overlap? Quadrant 3. Alright, again, tangent is negative. Tangent is negative. So tangent is going to be negative in quadrant 2 and quadrant 4. Sine is going to be negative in quadrant 3 and quadrant 4. And so the overlap is quadrant 4. Alright, secant. Secant is the reciprocal of cosine. So where is cosine negative? Cosine is going to be negative in quadrant 2 and quadrant 3. Tangent is going to be negative in quadrant 2 and quadrant 4. So the overlap is quadrant 2. And I did all of that by using a smart trig class. A smart trig class. Okay. So ranges. Look at the graphs on the inside back cover of your book, and it will help you to understand the range. Now, the range of a function is how far it can go in the y direction, positive y or negative y. And so what you have is the trigonometric functions from 4.1, 4.4, and like I said, it's on the inside of your back cover there at the top. That's what we're looking at. So for any angle theta for which the indicated function exists, number 1, your range for your sine is from -1 to 1. And if you'll look at that very first graph in that rectangle up at the top, 4.1 through 4.4, sine ranges from the blue graph, ranges in the y direction from -1 to 1. So that's going to be your range. And cosine also goes from -1 to 1. Number 2, tangent theta and cotangent theta. Well, if you see at the far right, you'll see tangent and cotangent, and you see that they go infinitely up and down. So they can be equal to any real number. That can be from -infinity to positive infinity. Alright, and then number 3, secant and cosecant. So look at those, secant and cosecant. Those are the two on the bottom left and the one in the middle. They can go anywhere from 1 to positive infinity or -1 to negative infinity. And we are talking about the blue graphs there on the inside of the back cover. So that is the range. Notice that secant and cosecant are never between -1 and 1. There is no graph that will fall between -1 and 1. So we kind of need to keep these graphs in the back of our head. We kind of need to keep our ranges in the back of our head so that we know if functions can actually happen at these spots. So decide whether each statement is possible or impossible. Well, cotangent of theta. Cotangent of theta can be -0.999. Cotangent of theta can be 0.999. Well, if you know your ranges, remember that cotangent can be any real number. Cotangent can be any real number, so this is very possible. And then cosine theta at -107. Can cosine theta be -107? Well, no, because it ranges from -1 to 1. So this is impossible. And then cosecant theta. Cosecant theta, can it be 0? No, because it cannot fall in between -1 and 1. So this is impossible. Alright, and these are the Pythagorean identities that I was talking about. Sine squared theta plus cosine squared theta is always going to be equal to 1. Tangent squared theta plus 1 is equal to secant squared theta, and cotangent squared theta plus 1 is equal to cosecant squared theta. And these can be manipulated, so we will manipulate these to get what we need. So for example, sine squared theta plus cosine squared theta, I can manipulate that to look like sine squared theta is equal to 1 minus cosine squared theta. So these can be rearranged to look the way we need them. Alright, let's try again. Cotangent theta. If we're looking for cotangent theta and we have tangent theta, well, this one's not that bad because cotangent and tangent are reciprocals of each other. So cotangent theta is just going to be 3 over the square root of 7, which is going to be 3 square roots of 7 over 7, rationalized. But we're in quadrant 3, and it is positive in quadrant 3, so we're good. 3 square roots of 7 over 7. Alright, number 4, secant and tangent. So we know, again, that tangent is y over x. Secant is the inverse of cosine, so that's going to be r over x. So we need to know what r is. So we'll have x squared plus y squared is equal to r squared. So we'll have 16 plus 9 is equal to r squared. And so we'll have 25 is equal to r squared. So r is equal to 5. Or if you know your right triangles, this is a 3, 4, 5 triangle, which would make it even easier. So secant theta is going to be 5 over 4. And we're in quadrant 1 and everything is positive in quadrant 1. So there you have it. Alright, last example. Find the other 5 trig functions given that secant beta is equal to negative 5, or negative square root of 5, and beta is in quadrant 2. Alright, so our angle is in quadrant 2, so we know that sine and cosecant are the only thing that's positive since we are in quadrant 2. So this is going to be negative 5 square roots of 5 over 1, and so this is going to be x, and this is going to be r, but we know that r is a distance, so that negative really needs to go with the 1. Alright, so we'll have negative 1 squared plus y squared is equal to the square root of 5 squared. So we'll have 1 plus y squared is equal to 5. So we'll have y squared is equal to 2. And y squared is equal to 4. And so y is equal to 2. Alright, so sine of beta. We're in quadrant 2, so that's going to be positive. Sine of beta is going to be y over r, so we're going to have 2 over the square root of 5, which is going to be 2 square roots of 5 over 5. Cosine beta is going to be the reciprocal of what was given, so that's going to be negative 1 over the square root of 5, which will rationalize into negative square root of 5 over 5. And then tangent of beta is going to be y over x, so we're going to have 2 over 1, or just 2. Cosecant of beta is going to be the reciprocal of sine, so we're going to have the square root of 5 over 2. Tangent needs to be negative because we're in quadrant 2. Cosecant is going to be positive. Secant was given, and so cotangent's the last one that we need to know. Cotangent of beta is going to be negative 1 over 2. Alright, so what I'd like you to do is I'd like you to try these problems on pages 36 and 37. If you have any questions, bring them into class.